Ladies and gentlemen, if you talk to teachers that have been teaching for a long time, longer than me, they often don't call this way of doing it elimination. They call it linear combinations. So I just want to, it's the same thing, okay? It's the same thing, but different vocab used. Well, let's be reminded here that we're going to start out with two variables typically and two equations. Well, it's difficult to solve it when you've got two variables, right? So your goal basically is to somehow rewrite it so that instead of having two variables, you have what? You just have one of them, and then you can solve it. Well, let's keep that goal in mind. Your goal is to write an equation in one variable. But it turns out that often you can eliminate one variable by adding or subtracting the equations. Often you can eliminate one variable by adding or subtracting the equations. Now this is kind of an interesting idea that you may not be kind of used to. It turns out that if you know two things are equal, well, because they're equal, same on both sides, if you take one equation and add it to another equation, the result will also be what? Will also be equal. So we're going to use that to our advantage today. And let's do this. Let's do an example. Let's solve. And let's start out with 3x plus 4y equals 8. And negative 3x plus 5y equals 10. And let me just remind you, you'll always be given these stacked like this, but that's not the way I like to start working them. So I always like to write them side by side. So I'll just write the top one to the side here real quick. And the reason for that is it just gives me plenty of room to work and everything kind of flows together. Well, what happens with elimination is instead of leaving them separate, and like with substitution, you would have to pick one of the variables and get it by itself. But with elimination, you actually go ahead and stack them and then look at what you have when they're stacked. Ask yourself, if I was to add or subtract these two equations right now, would any of the variables eliminate?
Yes. Excellent.
We're in good shape here, aren't we? If we were to add these two equations together, what happens to the x's? They're gone, so you don't write anything. And then what's 4y plus 5y? 9y. And what's 8 plus 10? 18. And can you now solve for y pretty darn quickly?
Yes.
You sure can. What's y going to be equal to? 2. Now, how on earth are we going to find out what x is equal to? So this last step is just like what we've done before, isn't it? Once you've found one of them, go ahead and take what it's equal to and sub it into the other equation. And that's why I like to write them side by side, is because I know where to go next. So we're going to have 3x plus 4 times 2. Clean it up a little bit. Where do we go from there?
Subtract 8 from both sides.
Subtract 8 from both sides. Uh-oh. Is this going to be trouble?
Why would it be?
Exactly. Why would it be? It's just what? It's just 0. And what's 0 divided by 3?
0.
It just so happens that our answer is 0, 2. The reason I mentioned that the uh-oh thing is a lot of people, for some reason, think when they're solving these that if they get x to be 0, that they've done something wrong, or that there's no solution. But isn't this a solution? Isn't 0 a solution? So we're in good shape. By the way, what could you do if you wanted to really super make sure that you got this right? Yeah, plug it back in. And that 0 kind of makes this easy, doesn't it? Check this out. Isn't that going to work out? Yeah. What about the other one? Oh, yeah. So it's a pretty easy way to do it. Let's try another one. Yeah.
Okay, so I actually wrote down the other problem and solved, and I still got the same answer.
Well, what do you mean?
Like, I did negative 3x plus 5y, and I still got the same answer.
When you took the 2 and plugged it back in?
Yeah.
Is that what you're talking about? Yeah, that's fine.
So it doesn't matter for me.
It doesn't matter. I just like having the other equation over here.
Okay.
The reason it doesn't matter is because with elimination, you've combined both equations to get this answer. So it really doesn't matter which equation you go into next. With substitution, you got to make sure that that first time that you get a variable by itself, you have to go to the other equation. Okay, you've got to have a mixture of the two equations at some point. Well, let's try another one, shall we? 4 plus 6y equals negative 5x, and 7x plus 6y equals 8. Kind of take a look at that. I'm going to take a roll real quick, and then we'll go over it. What do I always suggest you do first?
Let's see if we have any variables we can use.
Well, go ahead and write them side by side first. Now, here's the deal on this one. I'm not going to go ahead and start working it out right here because I have I just have my y's lining up. But does anything else line up?
No.
Okay, so I'm going to do a little bit of work here. This is called standard form of an equation, where it has x followed by y. I'm going to go ahead and write this in standard form. That way everything will line up when I add. Does that kind of make sense?
Mm-hmm.
So I'm going to add the 5x over, subtract the 4 to the back. So now I'm going to write 5x plus 6y equals negative 4. And now I think it'll be easier to work with. Right now, if I was to add these up, would anything drop out?
No.
No, they wouldn't. So that's why we say that you may add or you may what? You may end up having to subtract. And here's what you need to be cognizant of when you do these with subtraction is you don't just go minus 6y. Because can you just do that in an equation? Just change a sign? No. What you can do though is you can multiply the whole equation, right? By what? A -1, right? Now, normally I'm not going to do this step right here. I'm not going to show that step. But in fact, what we're doing is we're multiplying the entire equation by a -1. And because I did that, I'm going to rewrite everything. I know it's a lot of writing. I apologize. But if we distribute a -1, it's going to be -5x minus 6y plus 4, or equals 4. Now, does anything eliminate? It sure does. You guys see how you could have just easily let this alone and put minus, minus, plus? Yeah. So the y's go away. We're left with 2x equals 12. What's x equal to?
6.
Take that 6. You can sub it into any of the equations, but let's just go right there where we got room. Clean it up a little bit. Divide by 6. I think we get a fraction, don't we?
-5.
What is it?
-5.6. Or, oh, actually negative. Never mind.
Oh, okay. I think you're right about the -5. So it would go in 5 times, and then what would be the remainder? Wasn't 6 times 5, 30?
Yeah.
So what's left over? We got a 4 over 6, right?
Yeah.
So it's -5 and 4 6. But what is 4 over 6? 2/3. Yeah, 2/3.
Man, fractions are our thing.
Yeah, you guys are awesome at fractions.
Where do you get the -5 from?
Because the number is negative. You divide by 6, -6.
Oh, wait.
Yeah.
Actually, never mind.
Basically, 6
Oh, wait.
goes into -34, -5 times. That gets you to -30. But then you got a remainder of 4.
I switched the equations again, so I got confused.
Oh, okay. So we write our answer as 6, -5, and 2/3. Now, because we got that fraction, it's going to make checking our answers a little more strenuous, isn't it? A little more strenuous. But you can still check your answers. By the way, would an answer like this be very easy to get by graphing?
No.
Because can you imagine like 6, -5, and 2/3? You'd probably guess that it was like maybe at a half, maybe. You know what I mean? But with elimination substitution, you can get exact answers that are not pretty. All right, let's. Basically, before we move on, if your equations aren't in standard form, you're going to have to rewrite them. Is everybody comfortable with that? Yeah, it looks a little messy. Let's try another one. I think it's time for you guys to try one. Just to save time, I'm going to go ahead and write them side by side. Are you guys okay with that?
Yeah.
All right. 2x plus y equals -9. 4x plus 11y equals 9. Try this one out. Are they both in standard form?
Yeah.
Well, that's a good thing, right? So you're ready to write one under the other, right? And then you ask yourself, what do you ask yourself?
Any of them.
How does this make sense?
Any of them at 0, 0.
You ask yourself, add them up with anything eliminated. Yes.
The nines.
The nines would eliminate, but would you still be left with an X and a Y?
Yeah.
So would that really help you very much? What about if you just subtracted some?
Now you multiply the top one to make the thingy 4x,
Oh,
right?
well,
I don't
let's
know.
think about this.
Yeah, that's what I did.
Yeah, okay. So now let me double check here. So you said to multiply the top equation by 2?
Yeah.
If you did that, wouldn't you have to multiply everything by 2 to keep it equal?
Yeah.
Let's try that out.
When you just multiply by negative 36 enough times.
Okay.
I'm not
So if we just multiply by 2, it will make them the same, but we actually kind of want them to be opposite.
If you do -2 then.
So if we do a -2, okay, so I'm going to rewrite this down here. This is actually, the top equation is going to be -4x minus 2y equals what?
18.
What's that? What did you say, Silas? Did you say something, Silas? Oh, I thought you had a question.
I thought you said Sally.
So I rewrote it right here. I'm not going to rewrite this one because it's already there. Are you guys okay with that?
Yeah.
Now, am I able to use an elimination?
Yes.
I sure am, because what's going to eliminate? X's are going to go away. What are we left with? 9y equals 27. What's y equal to? 3. Nice work, nice work. And then what do you do?
Plug it back in.
Plug it back in.
Ew, I hate this. There's too much work that goes
Did anyone else get 4-1?
Huh?
No.
No.
Nobody.
I got like 3.
You just got answers.
I got 3 negative.
Wait, what?
Hey, 15. I got -3 3s. Am I wrong? Yeah.
Oh, I didn't add them. I subtracted. I'm a dummy.
I do know, yeah. I was like 4, 8.
Wait a second. Oh, negative sign.
I got -3 3. I did something wrong.
There we go.
I'm getting,
See, that's the kind of
dang,
thing that makes me feel.
is this -6?
Yeah, I got.
Yes, I got -6 as well.
-6 3.
What?
But yes, did it. Okay, but how do we know for sure? Check it, and always check in your original equations, okay? So -6, so that'd be -24 plus 33. Yeah.
Oh.
9. By 28.
Yeah, it checks out, doesn't it?
Yes.
It checks out.
Okay, well, I got it wrong. But it's okay. We're trying to go. I'm not.
That's
I
28.
don't want to do that. I didn't even finish this.
All right.
Hey,
We got time to do one more.
All right, we'll set up one more, and then it'll be time for lunch.
-9.
All right. So what was special about that one?
It was nice and set up.
Well, it was set up nice in that they were in the right order, but when you went to add them together, we had to multiply, didn't we?
Yeah.
We had to multiply. All right, let's try another. 2x minus 3y equals 6. 4y equals -7x minus 8.
What they gotta do with something?
It's okay. I'm. This is not it.